Hey everyone, welcome to Code Harmony. Today we'll solve LeetCode ID 3541. Find most frequent vowel and consonant. This problem is easy and I will try to explain it in a very beginner friendly way, and it will be based on the concept of hash table. Let's have a look at the problem statement. Here we are given a string S containing lowercase English letters A to Z, small a to small z. 26 letters we have in our string given to us, and our task is find the vowel A, E, I, O, U with the maximum frequency, and find the consonant. Consonant means which is not a vowel. Vowel means these characters A, E, I, O, U. These characters are vowels, and apart from that every other letter is a consonant. So find the consonant with the maximum frequency. So from the given string S, we have to pick a character 1, character 2. Character 1 is a vowel, character 2 is a consonant. And we have to choose these characters in such a way that these characters are having maximum frequency. Maximum frequency vowel and maximum frequency consonant. And return the sum of those two frequencies. So this is all we have to do. And there is a note: if you have multiple consonant and vowel have the same frequency, you may choose any one of them. And if there is no vowel, no consonant, in that case the frequency is 0. That's understood. The frequency of a letter is the number of time it occurs in the string. So just a definition of frequency. Apart from this problem statement, they are also given that a string will go around 100 letters in it, and the string will only contain lowercase English letter. That was the problem statement, and I will explain it again with the help of an example. We are given a string. This string is going to have lowercase English letters. These are from A to Z, and among those lowercase English letters we have to choose letter 1 and letter 2. Letter 1 is a vowel with the maximum frequency, and letter 2 is a consonant with maximum frequency, and we just have to return the sum of those two frequencies. Let's try to see what is that vowel. How many vowels are there? U, E, E. A, E, I, O, U are the vowels, and we have U coming out one time and E coming out two times. So these are the vowel frequency map. So we have captured all the vowels, and here I can see that vowel that we have to pick will definitely be E with the frequency of 2. And what about the consonant? In the consonant I can directly see that S is coming 4 times. S is coming 4 times, and all the others C is coming 2 times. So from the consonants part I am going to pick S with a frequency of 4. Now what we have to return is sum of these two frequencies, that is 6. 6 is going to be my answer. So that's all we have to do. First of all, we have to capture the frequencies of every single vowel or consonant, and after that what we can do is we can find out the maximum frequency vowel, maximum frequency consonant. Copy and paste. So what is going to be our approach? First of all, we can capture the frequency. And how do we capture the frequency? In a map? No. For that, what we can do is we can take a custom hash table. As the characters are going to be from lowercase English letters, which are only 26 in number, we can directly have a 26 size array Z with indices like 0, 1, 2, 24, 25, where the size is 26. So this array, let me name this array as hash. So I am taking an array which is going to include integer value, which is the frequency of particular index. So A I am going to map with 0, B I am going to map with 1, C I am going to map with 2, and this is YZ, and so on. So this is how we can map every single letter to the corresponding index. So we have 26 letters, 26 indices we have, and it is an integer array of size 26. Correct? And we can capture frequency of every single letter. And how do we capture the frequency? See, just iterate over every single character. Every single character of S. S dot character array. For every single character, what I'm going to do is hash frequency array. Corresponding array minus ASCII value of A. It means that A will be mapped to 0, B will be mapped to 1, C will be mapped to 1. Particular value will be incremented. So if I do this, I am going to capture frequency of every single letter from the string. String size can be around 100, but this frequency array will only have 26 blocks. So as I have captured the frequency, now we need to find out the maximum frequency of a vowel and a consonant. So for the maximum frequency, I don't have to iterate over the string again. I can iterate over the hash array, I less than 26 and so on. What I will do is, if it is a vowel, then I have to capture the frequency of that vowel, else it is a consonant. So this is something I need to do. If it is a vowel, capture the frequency in maximum frequency of a vowel and maximum frequency of a consonant. What value should I initialize these two variables with? We can initialize these two variables with 0. If there is no vowel, then definitely maximum vowel frequency is 0. Maximum consonant frequency is also 0. So these are the two variables. And if ith item is a vowel, later on we will see that how we can check this. If it is a vowel, if it is a vowel, then maximum vowel frequency is equal to maximum of current maximum and current frequency. And in this case, maximum consonant frequency is equal to maximum of maximum consonant frequency we have captured so far and the current frequency that we are getting. So by the end of this loop, we will have maximum vowel frequency, maximum consonant frequency. What they are expecting us to return is max V plus max C. This is something we can return from our function. So that's all what they are expecting. Firstly, what I did is I captured the frequency of every single vowel. The second thing is I captured the frequency of maximum vowel, maximum frequency of any vowel. So if at I item is mapping with the vowel, I'm just capturing it maximum vowel. If it is a consonant, I'm capturing in maximum consonant frequency. So how do we get to know that whether the I is a vowel or not? Let's take a set. And in this set, see, I have mapped my A to Z to 0 to 25 indices. And how I did it? Character minus first character. So this value, this integer value is the index in the hash function. The same I can capture in the set. Set is going to have all the characters which are vowels. And vowels are A, E, I, O, U. And the corresponding index to these vowels are A minus ASCII value of A, that is 97. 97. So if my index, if I index belong to this set, it means it is a vowel, otherwise it is not a vowel. So this is something what I did, and there might be some other ways to doing it, but I find it simple or straightforward. So this is something I did. When I iterated over the hash array of size 26, I checked whether it is a vowel or not. It means what I did is that set contains I, that vowel set contains I or not. If that contains I, it means particular I index is mapped with a vowel, capturing maximum vowel frequency, otherwise maximum consonant frequency. And in the end, it is the sum of these two. Now what is the time and space complexity? For time and space complexity, firstly I iterated over the string. in the form of string.character array. I iterated over the string with every single character. I captured it in a frequency set. So order of n time to iterate over the string. After that, I used a space of order of 26 to capture frequency, and after that I iterated over the frequency array as well, that is order of 26 in terms of time, and space is order of 26 overall. So order of 26 time for this loop and order of n time for this loop. So overall it is order of n. And what about the space? A 26 size custom hash table and a 5 size set. So it is order of 26 plus 5. In short, space is constant. So this is all about the time and space complexity. Now let's have a look on this code. This is the code that I wrote. Firstly, I took a custom hash table. I captured the frequency of every character. After that, I maintained a set. The set means that I can directly check whether the current index is mapped to a vowel or a consonant. So I just checked for a vowel because I have 5 vowel given in the program statement, and I can directly say in a constant time that whether the current index is mapped to a vowel or not. And after that, I capture the maximum frequency of any vowel and maximum frequency of any consonant, and later on just return the sum. So whatever is given in the problem statement, I just did straight away the same way. And here the time complexity is order of n, and n can go till 100. I hope you have understood the code, and it's a easy question which is going to teach us the concept of custom hash table and hashing set. So that is the topic here, and this is the easy problem to get started with hash table concept. Okay, thanks for watching guys. Bye bye.